is called More Integration Techniques. And what is the long story short of, what is the two-word, or actually it's hyphenated one-word, description of the section? U sub. U substitution or U sub. Now, hold on. This entire page, approach to integration, I'm not telling you what U sub is. We already did that. I'm not telling you steps 1, 2, and 3 for how to do U sub. We already did that. I'm saying when you get to an integration problem, think of the following. Does that make sense? So the first thing to think, I want you to think, is there a direct rule I should be able to go straight to an answer for?
Yeah.
And this one, in this example, there definitely was. And when you guys solve this, what should you end up getting? Yeah. And some of you, if you didn't know that rule very well, you'd be like, well, there's multiplication. I don't know what I'm supposed to do. Maybe U sub? And the answer is no. The integral of secant tangent is secant because plus c. The derivative of secant is secant tangent. That's a direct rule. Why no U sub? It's just of x. It's just of x. And guys, what if I did make u equal to x?
Well, you would just integrate it and get
du would equal 1 dx, and it would just change to integral of secant of u tangent of u du. It wouldn't change at all. You'd end up with the exact same answer. Number 2. Ooh, there's not a direct rule for that. Some people might think U sub because there's parentheses. Oh, okay, choose the inside. Okay. Choose the inside, but the deal is, guys, how hard is this distribution? Not hard. So why not just distribute really quickly? Not only will it be possible, it will probably also be easier than U sub, which might have also been possible. When we go ahead and integrate, we would just get 1/3 x cubed plus, you guys finished off, you don't need me. Keep going.
Shoot.
Could the AP graders do something like get a common denominator and pull out the fraction from the x terms? Yeah, they could. They could. But hopefully this one would be easy enough that you wouldn't necessarily need to do that. You could just make it match pretty quickly. I want you guys, if you have not yet, how many of you guys have solved all 3 of these? Exactly. Ready, set, in your groups. Who would you be? Take them 1 at a time. What would du be? And how would you solve? Maybe you won't get through all of them, but go. See how far you can get. Who would you be? Who would du be? Zach, go ahead and turn your chair, just because yesterday the collaboration wasn't working out so well. Thank you, thank you.
So, for the first one, u is 5x plus 7, because it's in the parentheses.
It's doing something important. That's going to use this time.
Wait, so... Come on, Tyler, I'm waiting for you. We're doing group activities. You're not here. Neither Sam, so what am I supposed to do?
You're supposed to do it and then give me the answers.
All right, Tyler, you're choosing the U and solving those.
I'm confused why we solved it.
Okay.
That's not light work.
I guess I need 4.
Well, but du is just dx 5.
Alright, so
Right.
you define integrator.
Because you end up plugging in dx anyway instead of du.
1 over.
Right? Wait, Misty. Misty. Why do you want to solve for du? Because we're going to plug in dx.
Okay. All right, cool kids. So, oh, you guys are cute. Question: what's U for the first one?
5x.
Yeah, 5x plus 7. So what did du end up being?
5.
Just 5 and then dx. And what do we do with du? Yeah. Solve for dx is the easiest way. Du over 5. So now I plug in, right? Did you guys end up with, after plugging in and simplifying, u to the negative 2 du?
Yes.
Does that make sense? The 5s ended up canceling, the du came in, the 1 over u squared you rewrote, right? So you end up with, maybe you can see why a BC kid could have done this all in their head. Once you get really good at it, you just kind of do this process and then, anyway. That's one thing about BC for any of you guys that might be thinking about it, is we get really, really good at the basics of calculus, which are really hard this year. When you take the integral of this guy, you add 1, right? U to the negative 1 divided by negative 1. So negative u to the negative 1 plus c, which ends up being negative 1 over 5x plus 7 plus How we do.
Good.
Questions? Remember, power rule. We had to make the 1 over u squared to be u to the negative 2. We add 1 to negative 2 to get negative 1. We divide by, remember, n plus 1 over n plus 1. When you divide by a negative, makes it all negative. Negative 1 puts it in the denominator, and I plugged in my u. Alright. Who was your u on the next one?
What was 5x?
What was your du? So, oh, just like this guy, huh? Except, when we went to go plug in, isn't there somebody extra?
5.
It's a 5, but careful, it's a 5 that's been divided by, which means I don't just pull out a 5, I pull out a
1/5.
1/5. Be careful, common mistake. A 1/5, and you get sine of u du. For those of you that aren't tracking, make sure you collaborate with your groups. If your whole group is stuck, get my attention. But when you go ahead and plug in du over 5, the one that comes out, Sam, we've only been on this one page. Okay, so you grab a picture of it. What is the integral of sine of u? Negative cosine. Good. Negative cosine of u plus c. Then we plug in negative 1/5 cosine of 5x plus c. You okay? So question. Does it make sense why?
Whoa.
The bunny dies?
Bunny's dying.
Why is the bunny dying in this one? The derivative of sine of 6x is cosine of 6x.
Wrong.
You
Times
didn't do your chain rule.
times u prime. This one needed a times u prime or times 6. So this should be 6 cosine 6x, right? Okay, this guy. The integral of cosine 6x. Oh, it's sine of 6x plus c. Man, this kid was smart. They knew integration. They knew the integral of cosine was sine, a positive sign. They knew they needed the plus c.
They need the 1/6.
But they're wrong because they had a
6x.
u.
They need the 1/6.
So think, if u is 6x, du is 6 dx. dx is du over 6. They needed a 1/6 sine of 6x plus. So that when you took the derivative, you would get cosine of u times u prime. The 6 needed to cancel out with something to get there. That was too much mental math. Come back here. Was the integral of sine of 5x cosine of 5x plus c? No. First of all, there needs to be a negative. Second of all, I need a 1/5. So that when I take the derivative and I do the u prime, it has somebody to cancel out with because there was no constant here in the integral. Does that make sense? So bunnies can die if you mess up derivatives or integrals. Chain rule mistakes can be made if you don't do u sub. Doesn't mean that you won't eventually get to being able to do some u sub mental math-wise. But what do you guys bet would be an answer for the multiple choice?
Probably the just the
Probably a positive, that's going to be there.
yeah.
Probably a negative. And possibly if they wanted to be super, super snazzy, they might actually have something to do with, I don't know, like a sign or something. No, maybe they do it this way. I think this is what I would do if I was them. I'd probably do something like that. If someone derived it, cosine of u times u prime, I don't know. They'd have different options, but long story short, you need the one with both the 1/5 and the negative. Does that make sense? Okay. Numero 3. I should say it'd be more like 3C. Who's you? X plus C. Some of you might have gotten confused on choosing that, and that's okay. Because there was an X to the one up top and an X to the one at the bottom, but the point is, isn't this guy innermost? He's stuck. Okay, what's du?
Yes.
Not very exciting because it's just 1. 1 dx. Which, this isn't going to be very exciting because what's dx?
Du.
So how on earth did this change anything if I could rewrite, don't erase stuff. If I could rewrite this to be x over u du.
You gotta consider that X.
You need this guy. Does So we just say, okay, wait, don't we have that guy in our workspace? So what are we gonna do with that guy? You think integration on cracker, you think whatever, I'm just doing substitution where I have x and I need him alone. So let's go plug in u minus 3 for that x.
Yes, let's go.
And when we plug in that u minus 3 for that x, we end up with u minus 3 all over u du. Wow, 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 it looks so similar. And yet. Are we allowed to split up fractions when I'm trying to split up denominators? But am I allowed to split up fractions when I want to split up numerators? By the property of common denominators, I can say, hey, I can divide the u by u and the 3 by u, which I affectionately call the heart method, but could also think distributing the division. U over u is just 1. 3 over u is just 3 over u. So why am I not rewriting the over u? I rewrote this guy, 1 over u squared, to be negative 2.
Because if you rewrite the to the negative 1,
There's a direct rule that says negative 1 is not good. Because negative 1 plus 1 is 0, all over 0. That's bad. That's really bad. Because isn't the integral of 1 over u, or similarly 3 over u, going to just be ln? So I go ahead and plug in. So I have x plus 3 minus 3 ln of x plus 3.
what if you minus 3?
Because the integral of 1
Oh,
is u. So I have x plus 3 minus 3 ln of x plus 3 plus c. Oh, there's a c right there. Right there. Anyway, if we wanted to be really nasty and AP-ish, we could have x plus 3 plus ln of 1 over x plus 3 cubed plus c. Anybody have any idea how I could write it as 1 over x plus 3 cubed?
It needs to.
Minus, and the 3 can come up as the power, and the negative 3 power says denominator cubed. But that's just being weird and AP-ish. You can box it there, and hopefully you can make it match. But remember, with logarithms, this can come up as a power and can change up how that looks. So, direct rules we've learned since 4.1 and 4.2. Trying to simplify, still 4.1, 4.2. Sometimes there's multiplication or division that we need to rewrite the integral with in order to be able to solve. However, sometimes there is a clear, or we're learning there is a clear u substitution that has to occur. And to be honest, kiddos, now that we've learned u sub, a whole new world opening up some. Is opening as far as AP problems, because almost every integration problem on the AP needs u sub. Almost every integration problem needs u sub in some way, shape, or form. Why is number 4 a little bit sad? If 1 doesn't work, try 2. If 1 and 2 doesn't work, try 3. If 1, 2, and 3 doesn't work, try 4. Sometimes careful division, which you've already seen us doing this kind of division, which is kind of like simplifying. However, maybe polynomial division might end up being super helpful. Multiplying by 1 creatively, multiplying by conjugates might come in handy. Substituting with trig identities. Ooh, we saw one of those the other day. Do you remember what I put on the board where we needed to substitute with trig identities? It was the integral of... Why did we need trig identities with this guy? U is tangent, and it's u squared, and du is secant squared, and he's not there. Let's not do u squared. Direct rule. There is none.
1 minus secant squared.
But there is a super snazzy Pythagorean property that said, you know what, you can make, remember this guy? You can make tangent squared of x into secant squared of x minus 1. And if we change that, why do I like secant squared of x minus 1 a whole?
You can cancel it.
I know him. He's tangent. I should be able to find him. He's x. Look, it was all possible, but if you just stayed stuck there, you wouldn't have ever gotten there. here's another good one. I think it's from homework. I think it's from homework. What if you were to see something like, I'll put it on the board, just for those who might be watching the video. What if you were to see something like the integral, another trig one, trig can get messy. What if you were to see one like the integral of cosine all over sine squared? That's a good one. There are two ways to solve it. Let's see if you can figure out one. Nathan just said cosecant. What on earth is he thinking? I think he's thinking, let's split up. You see it? Hey, look at these T-proof scales coming in handy. We can change up trig. Who's cosine over sine? Who's 1 over sine? Woo-hoo-hoo! Cotangent, cosecant, cosecant, cotangent. Isn't that a rule?
Yeah.
Can I just make that negative? Cosecant of x plus c? Okay. Whew, that was actually what I thought was the hard one. A couple of you went straight there. What's another way?
So, sine squared to 1 minus cosine.
That we have 1 plus cosine, 1 minus cosine. Actually, that's bad. I mean, it's not bad. It's a good idea. It just doesn't go anywhere. I was thinking,
Yeah, I think sine
like u equal to,
sine x. So
Right?
du equals cosine x dx, which equals du over cosine x. Because then when you plug in the cosine, it cancels out.
you guys see how it cancels?
Squared.
Isn't this just something I can solve? How would I solve u to the negative 2?
Yeah, add one.
Add one, bring it over.
Yeah, I brought it up to make it u to the negative 2. I need to add 1, so negative 1. Divide by. Isn't this going to be the same thing as? Should you be able to make these two match?
Yes.
Oh, I hope so. Two ways to solve it. That's kind of spiffy. Anyway, trig can be creative. There might be more than one way. There might be only one way. That was substituting the trig identities, and last but not least, adding by 0 creatively. And that's not even bringing in things from pre-cal like partial fractions, or we already said polynomial division. Anyway, that's not for today. Let's keep going. All that to say, there are many different ways to attack or to attempt an integral. And we're merely building on your tool belt. We're building on the skills that you guys have. Let's talk about U-bounds. U-bounds. So far, in every integral that we have done where we have done U sub. Pause. Pause. I know. I really appreciate you guys taking notes, but pause. I want you to look real quick. Pause. Look at every example that we've done. Have there been any bounds in this section? Any bounds? None. So what does this page say? What if? Keep writing. What if there are bounds and the integral needs substitution? You can't write the old x bounds when you go to use. Okay, keep writing. That's the idea. You can't write the old x bounds if you've changed to use. Does that make sense? Maybe not, but hopefully it will. You can't write the old x bounds. When you change to use.
Why is that? Yeah.
Remember how when we do use sub, we have to make sure everything changes? The function has to be entirely in terms of u. The differential has to be of u. All x's need to be substituted out. We need everything in terms of u. And those were x's. Are x's, exactly. So you guys remember your pictures for the area. The A and the B are x equals A, and x equals B. We need to substitute out. x's for u's. That doesn't mean that's the only way to solve. The only way to legally put bounds on a u sub integral is to change the x bounds to u bounds. And I know they're x bound because that little integral says dx. So everything's in terms of x, including a bounds. I'm doing u sub, but if I'm going to write bounds, to legally write bounds, I have to find u bounds. And u bounds in this one. Okay. U was the inner function, if you notice over here. U is the inner function. So ultimately, how you find the u bounds, this g of b and g of a, it really is just saying, hey, plug the b into u and get a u bound. Plug the a into u and get the u bound, and plug those in. In fact, when they put the g of b and g of a, they're really just saying, hey, find the u when x is b. Find the u when x is a. And it's very important, the symmetry. A needs to go with the u at a. The lower bound needs to go with the u at a. The upper bound needs to go with the u at b. You must keep the order the same. And one more time. You must substitute for the bounds as well. So legally show the bounds when solving with u sub. Now, what if you're like, well, I don't want to show the bounds with u sub? Could you just leave the bounds off? And then anti-derive. And then get back in terms of x's. And then bring back the x bounds. Yes, but the problem is you're ignoring the bounds for a while. What does your brain tend to do when you ignore something for a while? Forget that it's there. Does that make sense? So it's not bad to ignore them for a while unless you're like, I sometimes forget things. Maybe we shouldn't do that. And just a quick heads up, the AP does have a way of forcing you to understand u bounds, even if you choose not to use it on every single problem when we are solving with u sub definite intervals. That doesn't mean a lot until we actually start practicing. So are we ready? Okay. So we're going to solve two ways. One way is the ignoring way, and hopefully we don't forget. And the other way is nope, we're going to put reminders along the way. The nice thing is we're really only going to solve the integral once, and then we're going to use that answer for the next one. So we'll focus on the first one. What if I hadn't said anything about u bounds, and all of a sudden this integral shows up and has bounds? You're like, whatever, it's a definite integral. And all of a sudden you look inside and say, ooh, I need a u. What would we probably have done?
U equals x plus 1.
Some of you might think the square root of x. You could have tried that. It would have gotten messier instead of nicer. That's how you kind of know that a u sub isn't working so well. I would probably choose x plus 1 also. You could just try using x, but the problem is if you just chose x, nothing's going to change. Nothing's going to simplify. So we'll try making u be the addition. Du is just equal to dx, which means dx is just equal to. I go to plug in. I get du over square root of x times u. I haven't even gotten to my bounds yet, but first of all, I have an x, right?
Yeah.
Come on, guys. Yeah, it's immigration. I'm trying to have crazy immigration, but it's just saying I have an x. Go back and find x, right? Where is he?
U minus 1.
Got it.
Wouldn't we need 1/2 to the power of 1/2?
Yes,
U minus 1 to the power of 1/2.
Start to plug in, right? Question. Am I in some trouble?
Yeah.
Why?
Can't really distribute.
There's no rule that it matches up with, right? Can't really bring in the u to the square root, so it doesn't match. If I can't anti-derive, if I can't substitute. Remember what I said a second ago? And maybe I made you think it was a different route. I said if you try a U7, it just gets worse. Maybe you did the wrong U7. It's not bad for me to model that too. So who else might he be?
Yeah.
We could do 1 over, we could just do square root of x minus 2 square root of x. Square root of x, because you don't usually do the 1 over, that's our later step, right? That's x to the 1/2, right? X to the 1/2, isn't that 1/2 x to the negative 1/2? I'm gonna actually rewrite this first just to make our life a little easier. 1 over 2 square root of x. So now I get that dx is equal to 2 square root of x du. Then multiply 2 root x to the other side. Alright, let's see what we got. So dx is 2 root x du all over u times, oh, I still need x.
U squared.
You can go ahead and send. Guys agree?
When we also have to substitute on top too.
Couldn't we substitute on top? Because you guys realize we have another x that's stuck, right? And we can actually substitute 2 different ways. We could say, hey, let's plug in u squared for x, or couldn't we say we know who the square root of x actually is?
U.
Weird. So we could go ahead and say, well, wait, that's just the same thing as 2u du, and what Charlotte's noticing is, wait a minute, there's a u on top and a u on bottom? Yep. Maybe eventually I'll get to where you guys can actually notice this guy early. There is something special about this guy. U squared plus 1, we can pull out the 2, but what's so special about u squared plus 1? In the denominator.
And it's not the battery.
It's a specific rule. It's just not an integration rule that we've memorized yet, but it is the backwards of a derivative rule that we know. 1 over u squared plus 1? Inverse? Tangent. Now don't worry, we are going to memorize inverse trig integrals. But this is going to end up being tangent inverse
I'm sorry.
of u plus c.
I mean,
What's the derivative of tangent inverse of u? 1 over u squared plus 1 times u prime. There it is. Definitely did not look like inverse tangent to begin with, though, did it? This 1 over square root of x was your u prime. If your u had been square root of x, u squared plus 1. But the crazy thing is, you guys had no clue it was inverse tangent, but didn't we eventually, just by plugging in, get to the inverse tangent nice and pretty rule?
Oh my god, it's so fun.
Anyway, long story short, you're welcome for that. Long story short,
I really need to finish that.
when you plug back in for the x's, you get, for the u's, you get square root of x plus c. Wait, why do I need to be careful?
Because we have that bound of 1 degree.
We have bounds.
Bro. Okay, so do we just bring them down, or do we just take them out? Like, what do we do?
Well, check it. We ignored them for a while, right?
Yeah.
But we can't ignore them forever. That was the problem. So we have to say, all right, hey, hold on. We should have been remembering these down guys. Because now at this point, what are we going to do?
Bound them.
We're going to bring back in, why am I allowed to bring back in the x's?
Because it's
Just not in
I'm back to x's again. So what I did is I went to use for a while and ignored the bounds. And I'm like, ooh, bounds. And I brought it back in. Hopefully didn't forget. Struggle. Hitting all the wrong things. Then I would go ahead and plug in. And I would get 2. Oh, that's not what I wanted. It's a yellow. 2 tangent inverse of square root of 3 minus 2 tangent inverse of square root of 1, which is 1. Why are the c's not there?
Because you're
Because they subtract, right? Because it could have been plus c minus plus c. And then, square root of 3, that's the unit circle. If you're a cheater chart person, square root of 3 over 3, 1 square root of 3. It's going to be pi over 3. If you're I memorize my overs and ups. Mm-hmm.
These are just so nasty.
Tangent inverse would be sine over cosine. I need sine to be root 3 over 2, cosine to be 1/2. I need over a little and up a lot. I need pi over 3.
Pi over 4 for the next one.
And tangent inverse is 1, or I should say tangent is 1 when you have root 2 over 2 over root 2 over 2, which is the same thing as pi over 4. Struggle. Look at all the math on this guy. 2 pi over 3 minus pi over 2. Common denominators. 4 pi over 6 minus 3 pi over 6.
So wait, what is square root of 3?
If we do it the other way, we don't have to go through that, right?
Well, let's see.
No, you're probably not.
So there's no way out of it. We're all gonna die.
No, why are we dying? It's just the unit circle, guys. Come on.
Well, this is like
Wait.
And calculus.
really hard.
And derivatives and derivatives.
I guess not.
It's squares.
Sorry, I mean.
When you have,
Pause. To do it the other way, don't you still have to get to the exact same answer?
yes.
So what's going to change? Here's the idea.
Oh.
All that needs to stay the same. When you go down to here, and when you get everything in terms of u, or when you go to try to get everything in terms of u, here's the one change. Instead of stopping at dx, you're going to say, hey, who's u of 3 and who's u of 1? Before we go to plug into our integral, we do our u sub, do our du, find our dx, and then we say, oh, we're not done yet because that 1 and 3 has to change too. If I'm going to write numbers in this integral as my bounds, I need them to be u's. So I say, okay, u is square root of x, so plug in 3. U is square root of x, so plug in 1. So all that changes is when I go to plug in, at the end of the day, I'll end up with 1, the lower bound, to root 3, upper bound, of 2 du all over u squared plus 1. At which point we would still have to anti-derive. We would still need to get 2 tangent inverse of u, but the cool thing is we'd just be able to plug in the 1 and root 3. We wouldn't have to go back to the x's, and we wouldn't have to remind ourselves there were bounds. We have them already ready. They're right there. So we go to plug in 2 tangent inverse of root 3 minus 2 tangent inverse of 1. And kiddos, won't that lead me to the same answer of pi over 6?
So
You bounds just say, let's do this work early and then let's just put them in and use it for the rest of the time and never go back to taxes. You bound saying go to use and never look back. Here you go. So if you guys are lucky because I ended up not making it around the room because I forgot I was supposed to. So therefore, we'll spot check tomorrow. Finish.
Okay, Misty? Am I crazy?
No, maybe.
So they're gonna mark you a little bit? So they're gonna mark you wrong if you continue.